In this video, we are going to make a frequency distribution. Okay, so what is a frequency distribution? It is basically a way to kind of organize some data and really kind of be able to start to look at the data a little deeper. So we got 25 students that took some sort of a test or whatever their grades are, and here's kind of the list of them. But I want to organize it. So I want to figure out what kind of categories I should put this in, and then let's get some organization to it. So we have some scores, and they range from somewhere in the 60s, we got some 70s, we got some 80s, and we got some 90s. So I don't want to make too many categories. I don't want to chunk this into like 20 different categories, and then it's really no different than me looking at this. So the fact that I just already naturally said I have some 60s, some 70s, some 80s, and some 90s, that's how I'm going to categorize it. So a frequency distribution is basically taking data and chunking it. So I'm going to take and see how many values I have between 60 and 69, and then 70 to 79, and then 80, 89, and then 90 to 99. If I had 100, I'd probably throw 100 into this. So let me organize this. I'm going to put some tallies in here. And not coincidentally, these would be grades. So that 60 to 69 just naturally is a D category, a C category, a B, and an A. Okay, so I'm looking for how many of each of these things. So you can do this all sorts of different ways. I'm just going to go straight across and tally them what category they fit into. So I have a 76, and I cross stuff off to make sure I don't count something twice. I have a 90, and a 70, I have an 83, I have a 97, and an 87, I have 77, 88, and 93, 77, 93, I have an 81, I have a 63, I have a 79. So when I get to this is where I kind of make the mark for 5, so that I can count by 5s. That's a lot easier than counting all of my individual tallies. So that was a 70, and then another 70, another 70, another 70, 97, 87, 89, 68, 90, 84, 88, 91. All right, so that's where I'm sitting at. And I kind of want to know that I did this right. So let me take this and organize this just one more group of a little simpler. So I have 2 of these. I have 5, 6, 7, 8 of those, 8 of those, and 7 of those. So just a real quick spot check that this is 10, this is 15. Together that makes 25. So I've covered all my students. Perfect. So now I have a lot easier way of looking at my data and answering some questions related to it. So how many students scored 70 or above? We're looking at 70 or above. So we would have the 8 plus the 8 plus the 7. Or you could look at it the other way, and there's 25 students and all but 2 scored that. So 23. Or you can look at it as just adding what worked. Either way. How many got A's? Now it's very simple. Rather than me trying to count them all individually, I already have it organized. 7 of them made A's. And then what percent of the total grades were A's? So percent is going to be something out of something. So we had 7 people out of 25. And if you put that into the calculator, 7 divided by 25 is 0.28, which then makes 28%. So 28% of the class got an A. And then were the students prepared? As a teacher, does it seem like the students were prepared? Yeah. I mean, only 2 people got a D. We had no F's. So based on that, there's a huge portion of the people that got C's or better. 23 out of the 25. I definitely think the class seems to be prepared. So were the students prepared for the test? Yeah. Most seemed prepared. At least that's what the test indicates. Most seemed prepared. All right, and then what is the ratio of A's to F's? So ratio is can be a fraction, or it can be like A's to F's, or A's to F's. Okay. Well, apparently an F is something in the 60s in this group, apparently. So A's to F's is comparing this group to this group. Not sure how that would work because we missed it. But so we're looking at 7 A's. Apparently they're calling that F's. D's don't get degrees, so D's are going to be chunked into the F category. So we have 7 A's related compared to 2 F's. Okay, or depends on how they want it. It could be 7 to 2, right? That's one way to write a ratio. That's another way to write a ratio. So either 7 compared to 2 or 7 compared to 2. Okay. All right, that was frequency distribution. And it really is just a way to kind of organize your data.